Hello guys and welcome on my YouTube channel. So today we will review SFDC Secure Development cheat sheet. So as a part of any web application, it's important for us to follow security development best practices like building secure and good web application. So the same kind of items we would like to follow when we continue to building something on Salesforce platform. So especially it's important when we plan to release something on AppExchange because it requires a mandatory security review. So during the web development, we have some specific platform-related web application vulnerabilities. We have some general web-related vulnerabilities. So current guide will help us to understand what kind of practices we could use to secure our Salesforce web application and what we should do when we would like to pass, for example, AppExchange security review. So as a part of this guide, we will review XSS, CRUD, insecure sharing, insecure storage, SOQL injection, insecure external communication, and cross-site request forgery. So let's get started. So first of all, first item that we will investigate, it will be cross-site scripting. In other words, it's XSS. So it's standard vulnerabilities that we could see in top 10 of security issues and what should be resolved, because Salesforce recognize it as a critical when you will see on result of your checkmarks report when you will scan your application. So it's critically important to have it fixed. So mostly Visualforce and Lightning components have built-in output encoding to prevent XSS from user supplied data. But what could happen is sometimes our application use something that have, for example, escape false, and if we have it, it could potentially give us possibility for customers to input some user supplied data. So somewhere in Salesforce we have already available by default XSS protection offered by the platform, but if not, then what we should do is we need to use HTML encode or JS encode and manually apply it to the data. Also, we need to keep in mind that several locations do not enforce automatic output encoding and should not include user-specified input. So let's see what is the cause of XSS vulnerabilities. So here you could see then when we have something that is coming, for example, from the parameter of the page and it's directly inserted into the page and we have explicitly set escape false. So that means that encoding is explicitly disabled, and if there will be any kind of, like malicious code, it will be inserted to the page. So the same kind of item we have for Lightning. Next point, it's when we use user-supplied input in the JavaScript. So as you could see here, we're also getting from the current page parameter some value and putting it directly into our JavaScript code. It also should not be like that. Also, the same is applicable when we using styles, and inside of it we inserting something from the current page URL parameter or from the backend or from any other place. So the same is applicable for the all of kind of inputs that we have in the HTML. So for example, if we have on load, on click, on change and something like that, so we should not just paste here something that could be controlled by the customer. So it should be also escaped, encrypted. Oh, sorry. So also, if we have any kind of dynamic script invocation, like include script, and we dynamically trying to pass here script resource, so it's better will be to come from custom setting or from custom metadata, or if you will just use the name of the static resource directly, not just put it from the page parameters. So what is the remediation of those vulnerabilities? So first of all, we need to avoid using of escape false in Visualforce text such as output text. And because what it's disables the built-in Visualforce XSS protection. So as a workaround here, what we could do is we could organize our custom components that will allow us to render HTML without this additional escape false. But to do so, we, for example, will need to use something like DOM Purify library. So it's one of the libraries that Salesforce recommend when we would like to perform any kind of sanitization of our data. So what we need to do is we need to include this script into our Visualforce page or Lightning, and we need to load it from the static resource. And after that, it will be automatically available for us to use this DOM Purify library, and we will be able to sanitize any kind of our dirty code that we would like to be clear. And in the documentation of this library, you will be able to find like what kind of sanitization are available here. And also please note that if you would like to perform any kind of sanitization in other your static resources code, for example, when part of JavaScript code is in your static resource, then you need to include this library before your second static resource invocation to have it already available and be possible to use in this second static resource. Also, it's like recommended to not use unescaped HTML because the reason is the same. We are like using disabled version for the XSS protection. Also, we should not use user-supplied input directly into script or styles blocks, as we already mentioned. Everything what we are putting here should be encoded, GS encoded. For example, if we are using it in the GS context, or HTML encoded when we're using it in the HTML context. The same is that we do not need to place user-specified input directly into our JavaScript handlers. We should not do that also for script SRC. And if user-supplied input must be included for any reason into places that we just discussed, what we need to use is we need to use HTML encode or JS encode functions to do data secure. So for example, here we have this output text and we have escape false. And what is happening here, then we need to encode what is currently coming into this section. So to do so, if we have any kind of HTML that could potentially be malicious here, we just perform an HTML encode here. Also, we have JS encode if something becoming inserted directly into JavaScript code or into JavaScript handlers. Just for your information, we have the following functions that allowing us to perform escaping. It's JS encode, escapes data for use in JavaScript, JS in HTML encode, escape data that is used in JavaScript that is used in HTML code, like handlers, HTML encode, and URL encode. Okay, so one more recommendation from Salesforce, what we could use is we could use security filters package from Salesforce. So what this package allowing us to do, in general, it's the same that is DOM Purify library, and it's allowing us to perform anti-XSS protection when we have any kind of inputs from the client and we would like to not store it in insecure way and we would like to have it clear. So everything is here will be provided in the description of the current video, so you will be able to click and investigate it in a more proper way. So at this moment it's just for your information that this library allowing us to sanitize data. So also if we use third-party scripts like something from static resource folder instead of calling them from the remote location. So it's one more point that when we're using some code from the remote location, it will be great to put it into the static resource, because if third-party resource will be compromised, we will be able to still use our secure version of the libraries. So it's important because sometimes, for example, let's imagine we use some kind of libraries like jQuery, and we would like it to be secure. So what we could do is we could go to the following resource snic.io, and for example, when we here will search for jQuery, what we will be able to do is we will be able to check what kind of jQuery version, for example, have any kind of medium severity issues or high or low severity issues, and we will be able to decide what kind of library we need to download, put it into our static resources, and use it in our project. Yeah, so it's mentioned here that we should not use outdated libraries. So let's go now to the next item. It's CRUD. So in Salesforce we have CRUDs that allowing us to check if current user have permissions to create, read, update, or delete some object records, and also field level securities that allowing us to control user authorization and important concepts, you know, like if he could work with some specific fields. Because in Salesforce data is represented as object like account, case, or lead, opportunity, and stuff like that. In Salesforce we could control everything via profiles and permission sets, and CRUD and FLS, it's one of the let's say levels of authorizations that allowing us to check if current users that using our application is eligible to perform that kind of operation with this object or not. So one more time, CRUD settings allow us to enforce authorization on the object level. Field level security allow us to enforce authorization at the field level. So in Salesforce platform also could run something in the user context or, as you know, in system context. So let's see what is user context. It's when we do in something in Salesforce, like for example using standard Salesforce UI with no custom Apex code, when we using Visual Force page with a standard controller, when we using Visual Force page or references object using standard notation, also known as a references object directly, as you could see here. And when an application makes a standard API call, such as via SFDC SOAP or REST API, so in all of those situations, what is happening, we are working in the user context. That means that any kind of CRUD and FLS permissions are automatically enforced based on the current role of our user. Also, we have in Salesforce system context what it happens and when it's applied. It's when we are creating, reading, updating, or deleting records with Lightning. So unlike Visual Force, Lightning does not support any built-in authorization based on CRUDs and FLS. In custom Apex controller or extensions to standard controllers, we will also need to perform CRUD and FLS in custom triggers, in custom Apex web services, and stuff like that. In Visual Force pages, when we have, for example, custom controller, and when we have, like here mentioned in an example, some buttons that allowing us to perform DML based on some object. Here also we will need to check if in current context we are eligible to perform this delete operation. So what is the cause of CRUD FLS vulnerabilities? So when we have custom code, Apex, Visual Force, Lightning, that does not manually enforce CRUD and FLS, and one more time that if Visual Force not use standard controller or have custom Apex. When is creatable, is accessible, is updatable, or is deletable methods are not in use in Apex code when creating, reading, updating, or deleting data to enforce authorization, and when Lightning components do not use a Lightning data service when referencing the data. So here I would like to mention that generally it's not necessary in all places where you would like to perform, you know, like SOQL query, or when you would like to perform DML operation to put all this big number of checks, you know, like if current user have permission to, I don't know, to grab this data from DB if he has access to these fields, the following fields, and one more fields. So for all this stuff, it will be better on the architecture level of the project to have SOQL builder class and DML processor class, which will allow us to perform necessary operation, and they will encapsulate already necessary functionalities that will check for CRUD and FLS. And this part also could include troubleshooting, and if any kind of your customer, when he will try to perform any kind of operation, will have no access to something by mistake or it's by design, so this logger and troubleshooting functionality will log you an exception that, like the following user with the following profile don't have access, so you will be able to troubleshoot it. So one more time, it's not necessary before each line of your code that performs SOQL or DML perform a lot of code invocation to check if object is creatable, if user have access to the first field, second field, and so on and so forth. So what is the remediation of CRUDs and FLS vulnerabilities? So first of all, based on this guide, they asking us to ensure that custom controllers, extensions, triggers, asynchronous Apex, and Apex web service use checks that will make sure that our customer, before he will perform any kind of DML operation or SOQL operation, first of all, that our code will make sure that he eligible to do so. Okay, so CRUD methods can be called on the object or a field. As we could see here, we could just, after the object, put a subject type, get describe, and check if it's accessible or creatable, updatable, and so on and so forth. And when we call in one more note, that when we call in CRUD method on a field, it's automatically check the object level permissions. So it's just for your information, so it's not necessary to check additionally on the object level permissions if you will check for at least one field permissions. Okay, if we are using Lightning, the Lightning data service can be used by the UI to create, read, update, or delete records with automatic CRUD and FLS enforcement and no Apex code. So one more time, if you use Lightning, it's better to use based on the security ideas, it's better to use Lightning data service. But anyway, if you are using custom code, you will need to perform CRUD and FLS enforcement by yourself. So for example, by usage DML or SOQL processor invocation in a necessary place. Okay. Also, the note here is that it's critical to enforce CRUD and FLS in our enabled Apex methods, as Lightning components can call them. It's what we just discussed. So let's jump to the next topic. It's insecure sharing. So sharing is similar to the CRUD and FLS in Salesforce, but it's ensure that authorization rights are here to the specific records. So for example, CRUD FLS, making sure that user have ability to work with a specific object or a field, but sharing controls related to the user ability to view, edit, or delete records belonging to the other users. It's important note. So let's imagine that we have class with the following SOQL select statement with some number of fields. So if the class declared with sharing keywords or explicitly have this keyword with sharing, so what we will get as a result of this operation, we will get only records belong to these users. But if we will use without sharing, so that query will return to us records belonging to all users, not just to the current user, even if sharing setting on the object are configured as private, because Apex executes in system context and sharing enforcement must be explicitly declared to prevent user from accessing or modifying data that does not belong to them. So what is the cause of the sharing vulnerabilities? It's when custom controllers, triggers, asynchronous Apex or web service are not declared as with sharing. Okay, what is the remediation of insecure sharing vulnerabilities? So first of all, what we need to do is declare all controllers, triggers, and synchronous Apex and web services with sharing keyword. Sharing settings are applied to methods by the class are defined in, not the class they are called from. It's important note. And sharing is not inherited from an outer to inner class. Declare inner class with sharing as well. So if you have your class and inside of it you have inner classes, like for example wrappers or something like that, you also will need to make sure that they will have this resharing. And the important note, it's look like if we don't have in the inner class any kind of DML or SOQL operation, it's not really necessary to put this resharing keyword, but it will be better to add it. Child classes inherit resharing if it extends or implements a parent class, also important note. And if there is a need to update a record that user does not have access, so we will need to use without sharing keyword, because current user based on the sharing will not have access to it. So if it's necessary for us to do that, what we could do, or what should we do? We should have implemented DML processor or some utility class that will have false positive nodes that will explain why this place or this method is available, why it should be executed in without sharing, and we need to be really careful to with usage of the without sharing, because we don't want to some kind of protected data to be exposed by the mistake. So we need to really be sure about it. So next topic is insecure storage. So as a part of the insecure storage, what we could have, it's when in Salesforce we have some sensitive information like credit cards, API keys, encryption keys, sessions, passwords that in general could be recognized as a sensitive data, and we need to make sure that it will be protected by the good level. So what is a cause? It's when an application insecure storage some sensitive information. And for your information, when you have check marks report on your hand, even what you need to make sure is that your let's say protected sensitive data also should not be a part of the GET request, also not should be in the debug logs and stuff like that, and so on and so forth. So let's now go to remediation of insecure storage vulnerabilities. So when we using our sensitive data and when we stored it inside of Salesforce, we need to make sure that it's protected by one of the following methods. So one of the methods is usage of crypto class. So it's most applicable for sensitive user supply data such as password, credit cards, and stuff like this. And also you need to make sure that you will not hard code encryption key in Apex source code. We need to put our encryption key in a protected custom setting or protected custom metadata. Also, if you would like to work with crypto class, here you could see the following list of functions that is automatically available, like encrypt, that encrypts a blob clear text using the specified algorithm, private key, and stuff like that. We have also here decrypt method and stuff like this. All of this available in this crypto class in force.com. Okay, also what we should use is we need to use managed protected custom metadata type. Again, protected custom metadata or protected custom setting. So in a managed package, it's most applicable for storing secret which must be used by all the users of the package, such as an API key used by the application, and it's cannot be read by subscribing an organization via Apex or the API when the visibility is set to the protected for managed package. So the same kind of stuff, it's totally available for protected custom settings. Next item is named credentials. So named credentials are created by defining an external URL and credentials. So they are most applicable when storing authentication data for external services. So where we could create it, it's we need to go to setup, find named credentials, and work with it. But important note here is that if for any reason in your application a big portion of users have permission customized application, so all of them will be able to see these named credentials, and sometimes it could be not really secure, and sometimes you will need to think about additional usage of the crypto class, for example, and not store something in the named credentials. Also, when we have some sensitive user supplied data such as credit card number directly in the field of our object, what we could use is we could use encryption again, and we could encrypt custom fields, and only the way how it could be readable by the users, those users should have view encrypted data permissions. So next point, it's we need to ensure that sensitive information is not written to the application debugged, which is we already mentioned, and should ensure that sensitive information is not transmitted via URL. So that means that it should not be passed as a part of the GET request. So for example, when you're rendering iframe, when you're doing any kind of GET request to external resource or something like that, with all of those ways, you could expose your secure data. So Salesforce requires all sensitive information to be transmitted with post request. And also we need to make sure that Salesforce credentials like username, password, session IDs are not stored externally when integrating with an external application. So for that kind of purpose, we need to use Outflow to authenticate to an external application instead. And so we also should not hardcode our secrets, not in code, not in not protected custom settings and stuff like that, not in objects. So next chapter is insecure external communication. So because Salesforce is a multi-integrational platform, it's allowing us to perform integration with a different kind of third-party resources, and either as a part of the Compose application or by simply including embedded resource or link from outside of Salesforce in a native application. So the section details several best practices will include into this section. So what is the cause? It's when application insecurely integrates with external component. So when this component, for example, embedded from outside of Salesforce in our native application. So what is the remediation of external communication vulnerabilities? So first point, it's when we're using third-party libraries such as jQuery or other JavaScript, we need to use the static resource functionality instead of emptying them from external resources. So what does it mean? That if you have direct link to the external resource in your script SRC, then you need to replace it with URL4 usage in Visualforce, or for example include script in Lightning or LVC components from the static resource. In this way only it will be secure, because if this third party will be compromised, you could get potentially malicious JavaScript in your application. So second point is that we need to use HTTP over TCL 1.2 or above when communicated with some third-party resources. Also, we should do not include mixed content, like do not mix HTTP and HTTPS resources in our application, and ensure that everything is transmitted over HTTPS. Also, we need to ensure that Salesforce credentials like username, password, or session ID are not stored externally when integrating with the external application. And we need to use Outflow instead, because if external system have username, password, session ID or something like that, you will need to make additional step and make sure that external system is also secure. And if you will do this as a part of the security review for Salesforce AppExchange, it will give you like additional period of time when you will need to prove potentially your external application. But if you don't have access to it, it's usually very difficult to solve this problem. And also one more point is do not transmit password via GET request, as this request is insecure and it could be found in the logs, browser history, reference headers, and so on and so forth. So next topic is SOQL injections. So because sometimes application is built by the following way, when some developers put ability to get something from the directly from the page URL and putting into the SOQL query, or when they getting something from the input form of the customer directly and putting into the SOQL request, what it's allowing to do, it's allowing to perform SOQL injection. It's when we inserting user controlled data directly into SOQL query. In general, the best solution is also always the same, like use binding variables and use static query. So let's see what kind of remediation of SOQL injection vulnerabilities we could have. So one of them is assign user input to bind variable and use static query. So for example, here you could see that this query is static, so it's not dynamic, and we use here a bind variable. So this bind variable is secure by default and you don't need to do any additional action. So the second point is typecasting for all integer or boolean user specified input to their proper value. So for example, if you just expect a string to come in, what you could do is you could just put the following string value of and that variables that came to your page. So next item is when you get in something for example, from the user input, and what you could do is you could additionally use operation escape single quotes to not allow for the hackers to, for example, add additional part into your SOQL query and don't put here, like additional inner SOQL or some additional conditions to your SOQL. And also one of potential like way of resolve that kind of issue, you could use whitelisting or blacklisting and only accept those user inputs that are in the list, for example in whitelist, and reject all others. So for example, here you could see some kind of typecasting. So here we get the field from the page URL and checking if it's equal to this value or equal to this value or equal to this value, and only in that way we are performing this query, or in other case we will need to reject it. So next item that we would like to cover is cross-site request forgery. So our platform Salesforce automatically include cross-site request forgery token in forms when we creating them with Visual Force or Lightning. Like for example when we use an Apex form or Apex command link. The only way to introduce this vulnerability is to perform a state changing operation when we performing a GET request, which occurs via the, for example, when we have a Visual Force page and when we have action that becoming invoked when we have our page loading. By doing this, the entire class like and page gets this cross-site request forgery vulnerability. So what is the cause? The issue arises when developer bypass the built-in cross-site request forgery defense by making the state changing operation via GET request. What does it mean? It's, for example, you have Visual Force page, it has this action, once it's loading, it performs this action, and if it have any kind of DML operation, it's very dangerous, because let's imagine that if somebody will include your page that's doing this action on load, will, for example, by some way, for example, by the way of social engineering, will send you an email and it will have, like some hidden link behind it. Once you will be able to click on it or open any kind of site where it's loaded in as a part of the frame, this page automatically will perform that logic. So if you're, for example, an admin and this page will respect your rights, so it's very dangerous. So as a one-off situation I could provide, let's imagine that you're an admin and you have a page, and on this page you have this action that what it's do, it's grabbing from the page URL ID of the customer and automatically grant him system administration permission set. And if someone will find it by the way of social engineering, they could, like somehow hidely ask you to open this form, or it will be included as an iframe and it will be hidden, so we will don't know about it. And the idea of the hacker user will be provided, so you will perform this operation when you will grant him some kind of access when you will don't want it. So what is the remediation of the cross-site request forgery? We should not use GET request for a state changing operation because Salesforce platform automatically applies its protection on the post requests, and do not perform any state changing operation via the page action handler. And for your information, that if it's necessary, you could create your custom token, and it's should use in general, like any kind of encrypt decrypt functionality, because it should not be created that way when hackers could predict it. So it should contain like session information, some additional information, but it should hidden and should not be predictable by the hackers. So also under that video I will add links to some cheat sheets, so it will allow us to have quick references to like sharing keywords, nodes, CRUD, finless, Visual Force escaping functionality, crypto class, and stuff like that. One additional link to the cheat sheet with general the same, but with a little bit different view. And just I would like to talk about a couple of items. So when you try to perform security review via, for example, checkmarks report, you could get potentially additional vulnerabilities. It will be like a code quality. Here could be hard coding references to static resources, as we just mentioned, when it's the name of the static resources becoming grabbed from the page URL. It's not secure way, and we need to organize it by the different way. So also when we have Apex methods that not using collection but working based on the one record in general Salesforce as a part of the best practice, mentioning to us that we need to bulkify our code when we have SOQL or SOQL statement inside a loop, because it could give us the limits. Hard coding IDs, it's also not a good idea, because in different org it could be totally different ID. Your application will not work, and it's not a good way. It's not a best practice. Also, where you are querying some kind of data and you don't have where or limit closure, so that means that your code could fail, because your code could potentially on other org try to grab the number of records that is not under Salesforce limits. Also, when you have test methods with no assert, it's also a part of the Apex code quality, because if you have test methods that not really testing something, what is like those methods just only for coverage, code coverage. When you have multiple forms on the Visual Force page, it's also asking us to avoid it. But if for any reason you still need to have it, what you could do is you could organize your false positive document, make a note on the code level, and tell the Salesforce security reviewers why you need to have so. Also, when you have async feature methods inside the loop, again, it's understandable. False positive document, so what is it? So sometimes when you have in your code places where you, for example, need to use without sharing, or when you sure that, for example, it's XSS vulnerable, but based on your application, it could not be infected by the customers. So for all of these kind of use cases, we need to use false positive document. And in this false positive document, what we need to do is, for example, have a couple of columns like place, lines, explanation, and here you need to mention that, for example, in the following test page, in the lines, for example, 200, 210, we have, for example, some variable, and it's not escaped because it's only controlled by, and here you could specify the reason why it could be passed and why security reviewers should not return your code back to you and ask to prove this code. So here just you could see a couple of examples how we could potentially work with XSS issues when, for example, you need to get finally integer, but JS encode in Visualforce page only accept string variables. In that way, you could data that is coming from your backend convert to text. For example, it's applicable for float and for integer. You could convert it to the text, perform JS encode, and after that, what you could do is you could use JavaScript constructors. For example, when you use Boolean, you could use it, or use the following methods like parse float or parse int, and it will allow you to apply JS encode even in places where you could think of that it's could not be applied. And for Boolean, it's the same. When you have this Boolean just directly included into the Visualforce page, you could replace it to at least with the following. And by this way, what it will do, it will perform kind of typecasting. And in general, at the end, you will just get true or false. And you will see that potentially PMD will ask you to prove that place, but you could add a false positive note that nothing else than true or false will not be available after rendering of this code part. So at this moment that's all. I hope it was useful for you. So this video will have a name: Secure Development Cheat Sheet Overview. Thank you for attention. Bye bye.